My name is Charles Tran with the Novice Builder.
In today's video, we're diving into the essential process of installing hurricane straps, also known as hurricane ties. These metal connectors play a crucial role in reinforcing the connection between your roof trusses and wall plates, providing added protection against strong winds and storms. Let's get started. Before we begin, ensure you have the following tools and materials: hammer or nail gun, drill or driver, tape measure, pencil, marker or chalk line, level, and ladder. Materials: Simpson Strong Tie or H1, Simpson Strong Tie or H2.5A, Simpson Strong Tie or H2.5T, and galvanized nails or structural screw. Before starting, safety first. Wear your protective gear, check your tools, and clear the workspace. Part 1. Understanding hurricane straps. Hurricane straps are metal connectors designed to secure the roof structure to the walls of a building. They help prevent the roof from lifting off during high winds by creating a continuous load path from the roof to the foundation. There are different types of hurricane straps, including H1, H2.5A, and H2.5T, each suited for specific applications. These straps are typically made of galvanized steel to resist corrosion. Part 2. Installation steps. Step 1. Identify connection points. Start by locating where the roof trusses meet the top plates of your wall framing. These are the key structural joints that need to be reinforced with hurricane straps. To make this super clear, I'll walk you through the 4 key connection points using diagrams and real footage from my installation site. 1. Roof-to-top plate connections. This is the topmost connection, located in the attic or just under the roof sheathing. It ties the roof trusses or rafters to the top plate of the upper walls. Here, I'm using Simpson Strong Tie H2.5A. Two. Second floor wall-to-floor joist connections. At the base of the second floor walls, we need to tie the wall studs into the floor system below. 3. First floor wall to foundation, sill plate connections. This connection is where the first floor framing meets the foundation, a super important point to secure the whole structure. In my case, I installed hurricane straps at every connection point in the framing. I made sure each strap was aligned in a straight, linear direction to maximize strength and structural integrity. Ensure that this plate line is installed at or above the bottom of the rafter to prevent interference when installing the ceiling. Important: make sure to install these straps before the ceiling drywall is installed. Once drywall is up, access to these joints will be blocked, making it difficult or impossible to secure the straps properly. Step 2. Position the strap. Place the hurricane strap so that it connects the truss to the top plate. Ensure it's flush against both surfaces for maximum effectiveness. Step 3. Secure the strap. Using galvanized nails or structural screws, fasten the strap to both the truss and the top plate. Make sure to use all the designated holes in the strap for optimal strength. Step 4. Repeat the process. Continue this process for each truss-to-wall connection throughout the structure. Consistency is key to ensuring the entire roof is adequately secured. This is critical. Truss plates are metal connectors with sharp embedded teeth, designed to join wood members in roof and floor trusses. Once pressed into the wood, they form powerful joints that resist movement and carry significant structural loads. Truss plates aren't just connectors. They're key to the strength, stability, and safety of every truss system. Remember, proper installation of hurricane straps is vital for the structural integrity of your home, especially in areas prone to high winds. That's it for our tutorial on installing hurricane straps. If you have tips to share, feel free to leave a comment below. I'd love to learn from you. And be sure to check out the links in the description below to watch my complete construction playlist, or by subscribing to my channel, you'll gain access to all my in-depth tutorials, DIY projects, and step-by-step guides. Thank you for watching.
Make sure to hit the subscribe button and ring the notification bell so you never miss out my upcoming project and videos.
My name is Charles Tran with the Novice Builder.
Today we're getting into one of the most exciting and important stages of home construction, framing the first floor of my two-story house. Now, before I show you the step-by-step process, I want to explain how I approach this stage, especially if you're someone who's planning to build or budget your own home. This project highlights the financial benefits of managing construction independently. The total labor and material cost came to $17,000. By comparison, a local builder estimated $28,000, and Tough Shed quoted $32,000. This resulted in savings of $11,000 compared to a local builder and $15,000 when compared to the prefab option. These figures reflect savings of up to 47%, showing the potential of owner-managed or subcontractor-coordinated construction. For the second floor framing phase, the breakdown included $5,800 for framing and $2,284.93 for materials like plywood, Tyvek wrapping, and hardy plank siding. This phase alone resulted in additional savings of $4,436.77 over standard contractor pricing. So why I chose these contractors over Tough Shed and a general contractor? I decided to work with a contractor team that a friend recommended. They gave me a big discount and offered to do the job for $17,000, a price that beat all other offers. What made it even better is that they didn't just build the house. They partnered with me throughout the project. I supplied all the materials and tools, and they let me be hands-on with the work. They also took the time to teach me the process, so I'd be ready to take on future projects on my own. Now let's break down the actual tools and materials used to build it the right way on site. Tape measure, chalk line, framing square, speed square, laser level or spirit level, plumb bob, circular saw, hammer and framing nailer. Materials. Let's start with the structural wood. Section 1. Framing lumber. First, we have 2x6 Douglas fir, 24 feet long, number 2 grade. This heavy-duty lumber is used for long-span headers and beams, where strength is critical. Next is the 2x6 pre-cut stud, 104 5/8 inches long, kiln-dried and precision-trimmed. These are the standard wall studs for 9-foot ceilings. 2x6 Southern Pine, 16 feet long, number 2 grade. This is used for joists, rafters, and blocking throughout the framing. 2x6 pressure-treated lumber, also 16 feet long and rated for ground contact. This is ideal for sill plates or anywhere the wood touches concrete. I also use 2x12 Southern Pine, 16 and 10 feet long. These large dimension boards are great for floor joists, stair stringers, or deep headers. A standard 2x4 stud, pre-cut to 116 5/8 inches, is used for framing 10-foot walls. Then there's the 2x4 Southern Pine, 16 feet long, a go-to for plates, bracing, and layout studs. For framing tighter spans or blocking, we have 2x6 and 2x8 Southern Pine in shorter lengths like 10 and 18 feet. Finally, we have 2x8 Douglas fir, 28 feet long, perfect for long-spanning floor systems or heavy-duty headers. Section 2. Sheathing. For wall and roof sheathing, we use 15 32/2 inch 3-ply CDX plywood, often referred to as half-inch rated sheathing. Subfloors and structural decking are built using 23 32/2 inch CDX plywood, also known as 3/4 inch tongue and groove sheathing. Section 3, Insulation. R13 fiberglass insulation, 3.5 inches thick by 15 inches wide, covers just over 106 square feet per bag, designed for 2x4 wall cavities. For deeper walls or between floors, we use R19 insulation, 6.5 inches thick, ideal for 2x6 framing or floor insulation. Section 4, Adhesive and Fasteners. To bond and strengthen connections, we apply 28-ounce construction adhesive, like liquid nails or PL Premium, between framing and subfloor layers. Everything starts with planning, and that begins with the site plan. In this video, the site plan is used to help visualize how the first floor is framed using the structural materials that were planned out. We begin with pressure-treated 12x6 boards placed directly over the foundation. These act as sill plates and are crucial for moisture resistance and long-term durability. Next, we place 2x4 and 12x6 pre-cut studs are used to build up our exterior and interior walls, spaced evenly to hold up the structure above. Openings like windows and doors are framed with headers made from 12x4 or 12x6 beams. These help distribute the load around structural gaps. Over them, we lay 15 by 32 inch plywood sheathing, securing everything with construction adhesive to prevent squeaks. Before enclosing the walls, we insulate. R13 insulation fits between standard stud bays, while R19 is used where extra thermal resistance is needed. That's it for part 1. I showed you how much I saved on this project and gave you a diagram to help visualize and understand how the structural materials were used by the professionals I hired to frame the first floor. In part 2, I'll take you on site and show you a step-by-step guide of the actual framing process, in real action. Be sure to check out the links in the description below to watch my complete framing playlist or subscribe to my channel, The Novice Builder. It really helps me keep creating more helpful and engaging videos for you. And don't forget to drop your thoughts in the comments. I'd love to hear your tips, questions, or suggestions. Thank you for watching.
Make sure to hit the subscribe button and ring the notification bell so you never miss out my upcoming project and videos.
My name is Charles Tran with the Novice Builder.
In today's video, I'm giving you a look at how the professionals frame the stairs in my 2-story home. This part of the build is critical for safe and smooth access between floors, and it's amazing to see how the experts bring it all together. Before we dive into the step-by-step process, let me first show you how the original site plan compares to the actual construction. This is my original architectural site plan for the staircase layout, and this plan was fully up to building code before construction began. According to the plan, the stairs were supposed to have 6 steps, then a landing platform, and another 6 steps going up, totaling 12 steps. But in the field, the framer built it with 4 steps, then the platform, followed by 9 steps, giving us 13 steps in total. So what happened? The framer made a judgment call on site and adjusted the stair layout. This happens more often than you'd think. Some experienced framers will substitute their own judgment, thinking they're improving the structure or function. In this case, the original 6-and-6 layout may have looked awkward or unbalanced to them, so they changed it. Stair framing involves several key components. Here's a quick breakdown of what the crew worked on. Stringers. These are the sloped supports that form the backbone of the stairs. Treads. The horizontal steps we walk on. Risers. The vertical sections between each tread. Now let's break down the actual tools and materials used to build it the right way on site. Circular saw, speed square, framing square, power drill/impact driver, chalk line, tape measure, carpenter's pencil and marking tools, level, 2 feet and 4 feet, hammer/pry bar, nail gun, framing nail gun, and caulking gun. Materials: pressure-treated 2x12s for stringers, pressure-treated 2x6/2x8s for treads and blocking, pressure-treated 4x4s or 6x6 for posts or support, plywood/OSB for stair landing platform, concrete anchors or post bases if landing touches ground, exterior grade structural screws or nails, galvanized joist hangers and brackets, and construction adhesive. Before starting, safety first. Wear your protective gear, check your tools, and clear the workspace. Now let's get into the actual build. We started from the middle, building the landing platform first, then framing and installing the upper run of stairs. As for the lower stairs, I've got a whole separate video coming for that, so make sure you don't miss that one. Step 1. Frame the platform. Landing. The framers started by building the landing platform. This acts as a central point between the two stair runs and needed to be level, sturdy, and well supported. Step 2. Measure total rise to second floor. After the platform was framed, the framers measured the vertical distance from the top of the landing to the second floor. This gave them the exact total rise for the upper stair run. Step 3. Calculate rise and run. Using the total rise, they determined they needed 9 risers to stay within code, giving a riser height of around 7 inches, which meets the standard requirement of 7 to 7 3/4 inches. Step 4. Lay out the upper stringers. Once the rise and run were set, the framers laid out the stair stringers. They used stair gauges and a framing square to mark each rise and tread, then verified everything before making cuts. Step 5. Cut the stringers. They cut the stringers using a circular saw for straight cuts and a jigsaw or hand saw to clean out the corners without overcutting. Before committing to all stringers, one was test fitted first. Step 6. Install upper stringers. The upper stringers were then fastened from the platform up to the second floor. They secured the tops to the floor header using joist hangers and lag screws and anchored the bottoms to the platform frame. Step 7. Install risers and treads. Once the stringers were fully in place, the framers installed the risers and treads. They used adhesive along with screws to make sure the stairs stay tight, quiet, and long-lasting. Note: always apply wood glue before nailing stair components. Why? Because glue bonds the wood along the entire surface, preventing squeaks and adding long-term strength. Nails hold it in place, but glue locks it in for good. The adhesive being used is LNP 601 Project Construction Adhesive, Light Tan, in a 28-ounce cartridge from McCoy's. The framers load the cartridge into a caulking gun, cutting the tip at an angle and puncturing the inner seal to start the flow. Then, they apply a steady bead of adhesive along the framing surfaces, typically where treads, risers, and stringers meet. This adhesive helps bond the wood, reduce squeaks, and add long-term durability to the stair structure. Once the adhesive is in place and the wood is positioned, the framers use a New Tools SN2 283H 21-degree framing nailer, which includes a rafter hook for convenience and maneuverability on site. For this job, they're using Hitachi 10-1103 3-inch by .131 smooth framing nails, which provide solid hold and deep penetration, ideal for stair framing. The framers align the nail gun perpendicular to the wood surface, press the nose tightly against it, and fire with controlled, even spacing. Nails are typically driven every 12 to 16 inches, depending on the layout and code requirements. Step 8. Final check and adjustments. Before calling it done, the crew checked the entire stair run, making sure each tread was level, each riser was consistent, and everything was securely fastened. This is an important final step, especially when aiming for a clean inspection. And that's how the framers built the landing platform and the upper staircase in my home, all safe, solid, and fully up to code. The lower stair section that lead up to this platform will be covered on in its own video. But up next, we're moving on to framing the second floor full construction. So if you're following this build, you definitely don't want to miss what's coming. Don't forget to like, subscribe, and share this video if you found it helpful. Thanks for watching, and I'll see you in the next one.
My name is Charles Tran with the Novice Builder.
Today, we're framing the stairs, a key part of the build that connects the floors and has to be spot on. We start by calculating the rise and run to make sure every step is safe and comfortable. Then we cut the stringers, which are the angled supports that hold the treads and risers. Once the stringers are secured, we're installing the riser, the vertical part that gives height between steps, and the tread, the horizontal surface you step on, together forming each complete step of the staircase. If you want a detailed, step-by-step breakdown of the process, including the equipment used and essential safety measures, be sure to check out my full tutorial video in the description below. This time-lapse gives you a fast-paced view, but by subscribing to my channel, you'll gain access to all my in-depth tutorials, DIY projects, and step-by-step guides. Here's the process in action, shown in time-lapse. With the stairs framed, we now have a solid, safe path between floors, ready for finishing. Next up, plywood all around the house. Be sure to check out the links in the description below to watch my complete framing playlist, or by subscribing to my channel, you'll gain access to all my in-depth tutorials, DIY projects, and step-by-step guides. Thank you for watching.
Make sure to hit the subscribe button and ring the notification bell so you never miss out on my upcoming projects and videos.